nước đầu vào của cụm RO1 sẽ là nước nguyên liệu, nước đầu vào của cụm RO2 sẽ là nước RO1. Nước thải của cụm RO2 sẽ được thu hồi, tiếp tục cấp vào lại cụm RO1, còn nước thải từ RO1 thì sẽ thải bỏ thẳng luôn. Được chưa? Nó chỉ khác nhau chỗ thôi. Rồi bây giờ mình sẽ xem là cấu tạo của
To create our standard spiral wound membranes, we construct the flat sheet membrane using Hydronautics automated casting equipment. We begin the process with a fabric support base and then coat it with a microporous polysulfone layer. This provides additional support for the top 0.2 micron thick membrane barrier layer. This top barrier layer makes the actual separation to purify the water. The semi-permeable polyamide layer consists of a thin film of polymeric material a few thousand angstroms thick, formed on a porous supporting material. The semi-permeable membrane skin is formed on the polysulfone substrate by interfacial polymerization of monomers containing amine and carboxylic acid chloride functional groups. Hydronautics manufacturing procedure enables independent optimization of the distinct properties of the membrane support and salt-rejecting skin. The combination of these three layers makes a durable membrane flat sheet that is used in each spiral wound element. The membrane flat sheet is then combined with a sheet of feed channel spacer. This provides turbulence and creates space between the membrane sheets to allow uniform flow of the water to the entire membrane surface. The leaves of membrane and feed channel spacer are then combined with a sheet of permeate spacer, which provides open flow channels for the permeate even under high pressure. The leaves are glued along each of the three exposed sides and then rolled around the core tube. With the back of the membrane completely sealed to the edges of the permeate spacer, the feed water is forced through the feed channel spacer, contacting the front or barrier layer of the membrane. Clean water, or permeate, passes through the membrane surface into the permeate channel and then flows in a spiral direction to the center of the element and is collected into the core tube. Hydronautics spiral wound elements can then be loaded into pressure vessels and interconnected with additional elements to complete any number of design specifications. Once the end adapter is connected to the last element and the pressure vessel is sealed, feed water can be introduced and then treated. The feed water that does not permeate through the membrane becomes enriched in salts as it travels through the feed channel spacer due to permeate water being removed. Typically 8 to 10% of the water is removed in one 40-inch long membrane element. The permeate water then flows out the end of the vessel and is collected as the product, and the reject or concentrate from that vessel may then flow through another vessel producing more permeate. The remaining concentrate may then be disposed of as waste or partially recycled as the feed. Typically 70 to 90% of the water can be recovered as pure product water.
After passing the anti-scalant injection point, flow passes through the RO high-pressure pump, where the higher feed pressure is created for the RO feed water. After the high-pressure pump, the flow enters the RO's first-stage supply header. This header distributes flow to each of the 11 first-stage pressure vessels. As described in the RO Fundamentals section of this course, the first stage pressure vessels have two flow paths which exit the other side of the vessel. Flow which has passed through the RO membrane is collected from a tube located in the center of the pressure vessel. This water is called permeate due to the fact that it has permeated or passed through the membrane. It is also called product water, as it is the purified product water from the pressure vessel. Permeate is collected from all 11 of the pressure vessels in the first stage permeate water collection header. Concentrate flow is the feed water from which water molecules have been removed, with the contaminants remaining behind. The concentration of contaminants goes up due to the loss of pure water. Therefore, this water is called concentrate as it exits the RO pressure vessels. Concentrate which exits the first stage pressure vessels is collected in the first stage concentrate header. The first stage concentrate passes to the inlet header for the second stage pressure vessels. Feed water for the 5 second stage pressure vessels is provided by flow from this header. As with the first stage pressure vessels, there are 2 exiting flow paths from each second stage pressure vessel. The flow path which exits the site of each second stage pressure vessel is part of the second stage concentrate outlet flow. This flow path consists of the concentrated reject water from the first stage of the RO, which was further concentrated in the second stage of the RO. Second stage concentrate flow is the final reject flow of the RO system when it is in operation. This concentrate can be directed to the discharge water tank, where it can then be transferred to the solid contact unit or holding pond. Concentrate from the RO can also be sent directly to the neutralization basin, which normally occurs when concentrate is collected during RO cleaning or UF cleaning. Water collected from the middle port of each second stage pressure vessel is permeate water. Once again, it is composed of water molecules which have passed through or permeated the semi-permeable membrane layer of the RO elements. This second stage permeate is collected in a header which combines with the first stage product permeate. Permeate from the first and second stage of the RO travels to the degasifier, where it enters through a line that is dedicated to RO skid 1 or a line that is dedicated to RO skid 2.
Thì chứ đó là một cái hệ thống RO 2 lần. Dạ. Rồi giới thiệu thêm với anh chị về cái sơ đồ bảo quản và phân phối nước thì đây nó chỉ có một cái lưu ý là gì, mình thấy là nước nó hoàn lưu liên tục. Cái gì là không phải là chỉ khi nào mình mở cái vòi ra tại điểm sử dụng mới là nước nó mới chảy đâu, mà trong khi mình có không sử dụng thì nước trong hệ thống, trong đường ống nó vẫn luôn luôn chảy để làm gì ạ? Vì nếu như mà nước có đứng yên thì cái nguy cơ phát sinh vi khuẩn trong hệ thống là rất lớn, cho nên người ta phải cho nước luôn luôn chảy, và thậm chí trong cái thùng chứa vẫn có